What's up everyone, Patrick here, welcome back. Moving on to another system of equations where we have to solve for the x, y, and z here. And as usual, as I recommended in previous videos, I recommend you pausing it, trying it yourself, seeing if you get the same solution that I'm going to get at the end. So the way I'm going to approach this one here is I'm going to do substitution, and I'm going to isolate for the x in this equation. And then I'm going to plug in that expression for this x value and then that x value. So when I do that, I'll just bring the negative x over, so it'll become positive x, and then I'll bring the 3 over. So we'd end up having 2y minus 5z minus 3 is equal to x. So then I'm going to take this and I'm plug it in for this x and then that x. So let's keep track here of these equations. So this is just equation 2 rearranged. And then I'm going to take this and plug it in for equation 1 first. So we'd have, taking this, plugging it in for this x, we'd have 2y minus 5z minus 3 minus 3y plus z is equal to 4. And then I'm going to simplify this. So we'd have 2y minus 3y, which would give us negative y, then minus 5z plus z. Actually, let me just cross these out. Minus 5z plus z would give us minus 4z. And then the negative 3 I'll bring over. 4 plus 3 gives us 7. Right, so I'm going to leave this like this. So we have an equation in terms of y and z. And this was, we plugged it into equation 1. So now if we take this, equation 2, plug it into equation 3, we'd have 5 bracket 2y minus 5z minus 3 minus 13y plus 13z is equal to 8, like that. And then from here, you want to simplify, so I'm going to distribute the 5 in the bracket. Like that. And then over here, we'll simplify this, so we'll have 10y minus 13y, which would give us negative 3y. Then we'll have negative 25z plus 13z, which would give us minus 12z. Then bring the 15 over, we'll have 8 plus 15, which would give us 23. So now notice we have 2 equations, 2 unknowns, y and z. So now we could solve for y and z. So to do that, you could do substitution, elimination. What I'm going to do, I'm going to do substitution because of this y by itself. I'm going to isolate for it. I'm going to bring it over. So it'll become positive y, then I'll bring the 7 over. So we'd end up with y equals negative 4z minus 7, like that. Right? By the way, when we bring the negative y over, if we brought it to the right side, brought this over, we'd end up with negative 4z minus 7 is equal to positive y. This, they're the exact same thing. Right? Whether you put this on the left side or right side of the equal sign doesn't really matter. All right, so I just put it like this just to represent it a little more clear from left to right. So then what we could do is we could take this expression for y and plug it in for that y. So we'd end up with negative 3, negative 4z minus 7 minus 12z is equal to 23. Just want to make sure that all the algebra is correct. Yeah, it looks all good to me. So here we'd end up with 12z after we distribute the negative 3 plus 21 minus 12z is equal to 23. Now notice what happens. 12z minus 12z, that would give us 0z, which is just 0. Bring the 21 over. 23 minus 21 gives us 2. So we'd end up with 0 equaling 2. And remember, when you get 0 is equal to a number, it means there's no solution. So that's the final answer to this question. There's no solution. Another terminology you might see come up is that this is an inconsistent system. Right, so for this system of equations here, there's no solutions, or it's an inconsistent system.